Hello guys, hello everybody, welcome back to my YT channel. This is again I'm a singer, eternal voice. So it's gonna be back once again. I'm gonna back once again. Oh my gosh. So we have a heat exchanger topic again. So this is all about double piping exchanger counterflow. Okay guys, so I need to get the problem first before anything else. So I don't have to write, I'll just screenshot it. Okay, because I'm tired of writing. Okay guys, so it's gonna be here. So let's try this. This is not very difficult, a little bit average, something like that. And you need to have the basic concept of heat transfer through convection, and also the calculation and computation of heat energy, okay, from thermodynamics, and also a little bit physical chemistry. Okay, guys? And of course, we will not forget the basic concepts of general chemistry lecture regarding physical properties and chemical properties also. Okay, because these are all state of matter, liquid, gas, and solid. But in here, something like that. Wait for a while, I need to check. So now I'm increasing my weight, okay, but still my body mass index is in a healthy region or in a healthy state. Okay, I'm not obese, I'm not fat, something like that, and it stays there. I should maintain my weight to avoid and to prevent cardiovascular diseases, something like that. Okay, type 2 diabetes, or okay, high level of cholesterol, high level of sugar, obesity, and also hyperglycemia, and also myocardial infarction. You know myocardial infarction? Okay, this is the scientific or a medical name for heart attack. Again, myocardial infarction. Okay, guys. So where's that? Okay, and of course to improve my blood flow circulation. Okay, because we are having a genetic factor that is very, fat, okay, generation to generation. And that if we will just eat some plenty of, carbohydrates in 1 or 2 or 3 successive days, and we will become fat already. So this is genes also, right? Okay, that's why I'm really avoiding that one also. Oh my gosh. So from 82 kilograms, I am now 63 kilograms. And my blood pressure also works very well. 180 to over 80, something like that. Oh no, not 80. 120 over 80, sorry. Oh my gosh. Oh my gosh, where's that? It took me a long time to get the screenshots here. Oh my gosh. Oh, it's here, right? It's here in the other phone. But we're not lucky today that I cannot found it, okay? Oh, it's here. Okay. How can I zoom in? Because my eyes are not. Okay, in a counterflow double pocket exchanger, oil is cold COOLED, okay, from 85 degrees Celsius to 55 degrees Celsius by water, entering at 25 degrees Celsius. Oh my gosh. The mass flow rate of oil is 9,800 kilogram per hour, and the specific heat of oil is 2000 joules per kilogram Kelvin. The mass flow rate of water is 8,000 kilogram per hour, and specific heat of water is 4,180. Oh my gosh! This is a wrong unit. So imagine. So they are giving a problem that's a wrong unit. Here, 4,180 kilogram per hour. This is mass flow rate. I think this is only clearly column. Okay? But this is not good, right? Giving problem or problems to be solved, and then some students will obtain the sample problems, and oh, it's so very embarrassing. Okay, because that is reference, and then giving the wrong unit. 4,180 kilogram per hour is not. It's 4,180 joules per kilogram degree Celsius. I think so, but let's investigate. We convert first before going further because they're giving the wrong unit. Okay, so determine the heat exchanger area and heat transfer rate for an overall heat transfer coefficient of 280 watts per tube. The tube if inner diameter is 0.1 meter. Okay, so inner diameter. So our outer diameter is not considered here. Okay, because normally the fluid or the liquid will flow inside. Okay, so the fluid and the liquid will touch the inner diameter, not the outside diameter. Okay, so that's the reason behind. So okay, so we will still use the logarithm mean temperature value or the TLM. Please be reminded that if you compute for shell and shoal heat exchanger, finned heat exchanger, spiral heat exchanger, or this double pipe heat exchanger, we need to account the area, surface area is equals to pi dl, not the pi r squared and not the pi, the one technique here. Okay, and then before anything else, guys, we need to, how shall I say this? We need to calculate the specific heat capacity because they are giving the wrong unit. Okay, so things like that is not good. Okay, there's no review and double check and proofread of your sample problems in the in the online world with so many little research, and then especially to those people who are having a science graduate or engineering graduates pertaining to science. Of course, we're very particular to that. Okay, so let's convert first the 4,180 joules kilogram Kelvin, because I doubt also that's going to be joules kilogram degree Celsius. Okay, I doubt only. Oh my gosh. Okay, so I have here 4,000. Oh my gosh. 4,180. So what is the standard temperature for this equivalent specific heat capacity? So this is, I think, I'm not really that sure, but let's just to make it parallel with the density of water. Okay, so anybody have an idea for this? Okay, I must double check this also in other references. Okay, because the density of water is 1,000 kilogram per cubic meter. Okay, 62.43 pounds per cubic feet, 1 gram per ml. Okay, like that. So, or 1 gram per cubic centimeter, because ml is just equal to cubic centimeter, right? Okay, and then that is at 4 degrees Celsius, but I don't know if we have a standard value of specific heat capacity, if it is also under the temperature of 4 degrees Celsius. It's gonna be 25 degrees Celsius. It's either the two. Let's check. But I think 25 degrees Celsius, right? Unless otherwise specified. So, because all standard temperatures are room temperature, 20 degrees Celsius to 25 degrees Celsius, normally, if not specified. Okay, in certain problems. Okay, science problems with regards to heat, energy, or temperature related problem solving, something like that. Okay, so specific heat capacity, this is denoted as letter C. okay, is equal to, let's start with 1 gram per degree Celsius. Guys, if you have the unit also, then if the examination requires you to have definition and explanation, you can also, aside from you can troubleshoot the formula if you forget it, you can also define by your own. Okay? As much as we could, we need to avoid to be bookish. Okay? You know, bookish, everything refers to the book. We have also our own, shall we say, discarte in problem solving or in any memorization or in any understanding of, you know, technical scientific knowledge or any scientific concepts of pure sciences. We will not rely purely on the books also, okay? So the books will be our reference, our sources, right? So that would be beneficial. But aside from that, if, for example, if it is phrased in that way, we can have our own. Okay, we will only troubleshoot, okay, the terminologies, and we will not memorize as it was. Okay, we need to change a word that is more common to us so that we can easily memorize. Okay, so that also makes us complicated to memorize because in the first place, not all books are using common terms to understand also. Okay, so it's very difficult to, you know, to memorize something, especially if the words are not common to you. Okay, and then you will go to the library and go to your mini library in your room, and then you have to refer to the Webster dictionary. Okay, something like this. Let's just say this: at standard temperature, the water has a specific capacity of 1 calorie per gram degree Celsius. This was discussed in general chemistry lecture, first year college. I think it's gonna be lecture 1. Okay, because in high school this is not yet discussed very well about specific capacity. Okay. So I think this is 25 degrees Celsius, 1,000 resource. So for example, what is the define what is the specific heat capacity? Since you have the unit, it's very easy to say, okay, that is an amount of heat energy necessary or required at given temperature and mass. Or it is a heat energy necessary or required per unit of mass and its temperature at 1 degree Celsius. Because this degree Celsius is also 1 because there's no number in the denominator. So through this unit, guys, you can create your own definition. You get the point? So understand that this fraction is only per, per, as per unit, blah, 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 as per unit, blah, blah, blah. This is the definition of the fraction. For example, pressure is equal to force over area. So you will say it is a perpendicular force applied as per unit surface area. So the word per, per, meaning to say that is a fractional in form. Okay? You get the point? For this is the clue in algebra or in any science. Per is numerator over the denominator. For example, grams per ml. So we need to say that this grams like this per ml. So it's the same like this. Okay, so it's very easy to troubleshoot the definition for this. Do not rely on the books or in the whatever sources. Through the unit alone, you can formulate and create your own definition. Okay. Like that. So I practiced this when I was in college. Okay, so I troubleshoot the mathematical operation, and then I translate it with mathematical operation, and then so that I can really understand well. So I have the formula, I have the operations, and then I have to get the equivalent terminology for that, and then little by little, I memorize, I understand, like that, and then continuous process, repeat it again, okay, like that. It will be used from first year college to fifth year college. Okay, so if you really understand, so sige rambol pa siya, makasabot na jud ka. Okay? Because you understand really the dynamics or the mechanics on how to understand through thorough memorization. Thorough, okay? So this squat, 1 calorie per gram degree Celsius. Ano yun siya? Ang 1 calorie gram degree Celsius class, we need to convert this. So 1 calorie is equals to 4,184 joules, right? Okay. So, calorie is very important in burning of fats, okay, during the metabolism, okay, the breaking down of large substances into smaller substances. Okay, the smaller substances can be transformed into wastes or toxic wastes that is in the form of sweat, or could it be in the form of human waste, or a fecal, or a stool. So that's a, the byproduct of metabolism. Okay, so muna siya yung mga calorie or kilocalorie. So if you found that, usually you found that in foods and drinks, in your byproducts in the market. Okay, that's the unit of heat energy. Okay? Calorie, kilocalorie. Saturated fats. Oh, how many kilocalorie and calorie? Okay, saturated fats. Unsaturated fats, cholesterol. Ganun. Okay, but sugars are, there's no addition of sugar, meaning grams and milligrams only, but what I mean is the heat energy, okay? And what else? The cholesterol level, mga ganun siya. Okay? And a whole lot more. Just go to the package of the food products and drinks products, so it will be reflected there, okay? Kilocalorie and calorie, that's the unit of heat energy, okay? Okay, so now 1 calorie is equals to 4,184 joules. Okay, so we can say that, okay, or anyhow, we are not really that concerned with this conversion to joules, okay, because our unit is watt per meter squared Kelvin. Okay, so in here, guys, again, sorry guys, oh my gosh, 4,180. I cannot do this spontaneously because the letters are very small in my mobile phone. See, I have to zoom in so that I can read it clearly. Okay, so I just have to prove why it is a 4,000. I confused, or it could be joules per kilogram degrees Kelvin. I have to prove that one, which is correct, the joules per kilogram degrees Celsius or the joules per kilogram Kelvin. I memorized before. If I will trust my memory, it is joules per kilogram degrees Celsius. Now, since I am perplexed, it's gonna be joules kilogram Kelvin. Okay, perplexed meaning I'm confused. Okay, another term for confused, and like that. Okay, so let's convert this one, so 1 calorie. Okay, so this is gonna be, guys, 1 calorie. So we'll start with 1 calorie in the denominator. Okay, so that we can cancel that out. This is the procedure. Okay, so 1 calorie. So since this is 1 calorie, and then convert that to kilocalorie, so we will say 1 kilocalorie in the numerator is equals to 1,000 calorie. Okay, something like that. Or it's gonna be 1 calorie in the denominator is equals to 4,184 joules. Anyhow, we say that watt is equal to 1 joule per second. Okay, remember the formula in practical electricity. Power is equal to work over time. That's why we have 1 watt is the unit of power is equals to work, and the unit is in joules. Okay, and time is unit in second, standard unit. So that's why it will become joules per second is equal to 1 watt. Okay, that's where it comes from. It's not magic, it comes from there. Okay, so 1 calorie is equal to, so 4,184 joules. Since our unit are dealing with joules, then we need to come up with joules. Okay, like that. So, these guys, 1 calorie for 1 calorie. No, 1 calorie is also for 1 joules. Cancel the calorie. What left will be joules? Okay, like this. Tank, tank. Now, since that is kilogram pa siya, so 1,000 grams in the denominator is equals to 1 kilogram in the numerator. So, 1,000 grams in numerator, okay, 1 kilogram. Cancel, cancel, okay, it's gonna be, actually, if it is Celsius, guys, this is, calculator, please. Okay, so this is 4184,123. Oh my gosh! So if we need this as joules kilogram degree Celsius, this is 4,104,000. So this is wrong. So it's gonna be joules per kilogram Kelvin. Let's try. Okay, so it's gonna be like this. So if it is a Celsius and a Kelvin, right? So how many Celsius in a Kelvin? So you can do this, right? So Kelvin is equals to degree Celsius plus 273.15. Oh my gosh, like that. So how can we do this? So degree Celsius, okay, degree Celsius 184 joules kilogram degree Celsius, okay, then 1, okay, degree Celsius 1, Celsius to Kelvin, right? Celsius plus 273.15, and this is Kelvin already, right? So cancel the Celsius. Oh my goodness. So this is gonna be, if you, okay, so this is gonna be, so Celsius 1 plus, okay, Celsius, and then 273, okay. So this is gonna be Celsius, i-times na mo siya, Celsius, okay, divide Celsius, 273.15 Celsius, then cancel, ganun siya, chuba-chucho, okay, and then 1 Celsius, okay, cancel mo siya. So that is 273 to 273. So 273 to 273. Wait guys ako yung i-prove because I don't want to solve na mag-ibuko, diba? 273.15, okay, ganun, divided by 1, no, it's close to 2, okay. Listen guys, right? So, okay. Now, 1 calorie mo ang standard no. Then 1 calorie is equals to 4,184 joules. Okay, so that's mean 4,184 joules 1 calorie. Okay? You get the point? Since this is million, guys, if we convert this to kilojoules, how much? Kilojoules. So 4 million, because it's not very easy to convert Celsius to Kelvin without any numerical figure. In here, there's no numerical figure here. See? This is only 1 degree Celsius. Okay, so how can you do that? Okay, so in every Kelvin, how many degrees Celsius is that? This plus 273.15 supposedly, right? So 1 degree Celsius plus 273. We are doing the linear algebra, and there's a plus post the Celsius. So let's say the common there is Celsius. So Celsius plus ganun chuchu, and then the other one is 273.50. It's very difficult to cancel. Okay, I can make it, but I have still to think. Okay, this is not our center of discussion. I have joules. Complicate man siya, guys. Okay, because there's, remember in algebra, right? If you have plus and you have the variable, so if we do that, we need to distribute one by one. And then we can get linear equation for that. Okay, so there's another variable problem for me to, to make it complicated already. So 4,184 joules. Okay, joules naman siya. Then, okay, 1,000 joules, 1 kilojoules. Ganun. Okay, so convert siya. 4,184,000 divided by 1,000. So this is gonna be 1,184 kilojoules per kilogram degree Celsius. So it's not joules. Okay guys, it's not joules so really. Okay, let's review the other specific unit. Okay, because there's an oil, counterflow with the oil. Let's check. Because I obtained 4,184 kilojoules per kilogram degree Celsius. So in this way, we need to we need to see the other specific heat of another substance, which is the oil. So if the unit is equal, meaning we need to use this kilojoules. Okay, and we need to verify it. Okay, it's very small. So again, the mass flow rate of the oil is 9,800 kilo per hour, and the specific heat of oil is 2,000 joules kilogram Kelvin. It doesn't agree, so it means joules kilogram Kelvin. Okay, so and I have the water, which is 4,180 kilojoules per kilogram degree Celsius. This is a confusing, right? This is a problem, sample problem, but I think this is wrong. In the first place, it's already wrong because kilogram per hour is mass flow rate. It's not specific. Patakakaloka, di ba? Okay, so I have to correct it. Imagine. Okay, and then, if I will convert it to 4,180, just to say that the figure is equal, and then the unit also will not equal to the specific heat of the oil. Because the specific heat of the oil is in terms of joules na yun siya. Nakalibig pa yun ang denominator. But we need to, so how can we do this? We need to convert the other one, the 2,000 joules kilogram Kelvin. So, let's just assume, guys, that this specific heat capacity of oil is correct. Already, right? Which is 2,000 joules kilogram Kelvin. So we need to make this 4,180 kilojoules per Kelvin degree Celsius to the same unit with this 2,000. So let's say, kaloka. Why not making the same unit so that we can solve directly? Okay. Kaloka, guys. Diba, guys? Nakakaloka talaga siya. Okay, now, so I have 2,000. So let's say I have to put down the data now. The first thing is to put the data first, given the data, so that I will not keep on looking to the, to my mobile phone. Oh my gosh. See, the condition is a counterflow double pipe heat exchanger. So this is our type of heat exchanger that we have. So double pipe heat exchanger. Okay. So in this is the first step to identify what kind of equipment we have. Because each equipment has its own corresponding applicability of the formula and equations before we can connect or before we can link the heat transfer formulas and equations and also the formulas of heat energy for this. Okay? So that's the first thing. Number 2, jot down or list the data. Okay, the data. Okay, so oil and water is our substances here, oil and water. Okay, and then the oil exchange. Oil is cold, meaning the oil is being cold, ha? So meaning to say the oil is more hotter than the water, of course, because it was being cold, right? So oil is cold from 85 degrees Celsius to 55 degrees Celsius. It is very sabotable also because it starts from 85 degrees Celsius and then going to 55 degrees Celsius, meaning to say it's very hot. Not really that very, it's already hot and then it slowly drops to 55 degrees Celsius. Okay? Okay. By water, the water is entering at 25 degrees Celsius originally or initially also, but the temperature of water final is not mentioned. Okay? Like this. The mass flow rate of oil is 9,800 kilogram per hour. So mass flow rate of oil meaning MFR, or let's just put that in this way, M. Okay? Because sometimes, sorry, kutasan ko. So sometimes guys, we need to add subscript because small letter m alone in our general chemistry lecture or even in our physical chemistry or physics, that's simply mass lang talaga, good siya. In grams, in kilogram, in pounds. But in unit operations, or shall we say in thermodynamics or in the fluid flow, okay, fluid dynamics or let's say transport phenomenon, momentum transfer. When we say of small letter m, that is mass flow rate. Okay, now mass flow rate, guys, is not the same as mass alone. As I told you over and over again. Okay, and then why we designate also as m? Because it's all about masses. And it's mass flow rate, and it's addition of flow rate. Meaning to say, it's just like a speed. There's a time in the denominator because that's a rate. Okay? Something like that. So, this is kilogram per second, pound per hour, like that. So, this is mass flow. It's not only massa, kilogram lang siya. Okay, kinaman siya times sa denominator. So, that is mass flow rate. So, for me, I can put MFR, mass flow rate of water. And in the books, they don't put FR because understood. Okay, understood. But to be precise more, we need to put FR, M subscript FR because it's referring to mass flow rate. Okay, in the books, sa butable or understood na siya, put only M. But M is not the same as mass flow rate. Mass is just a mass, it's not a rate. Okay, so this is why I put MFR. Let's agree. Okay, anyway, this is not really minor, this is only minor chupa-chucho, but I need to be precise in my discussion because there's a difference between mass flow rate and a mass alone. Okay, mass meaning regardless if it is moving or not, it's just a mass. But when you say mass flow rate, it will move because there's a rate at a particular time t or a period of time. So that's the clear difference, right? So I need to emphasize the subscript FR, meaning mass flow rate. Okay, and FR. Ganon siya kakaano ka detailed or shall we say clarity, okay, of the discussion. So MFR, okay. As much as we will try to discuss it in more clarity compared to the books. Okay? Because this is our own understanding how to deliver the discussion. Because the books will not discuss very well. Okay? It's just automatic like that. Very quick. And then it will come up to this, and we don't know where it come from, like that. So,
the Bluetooth device is ready to pair.
Mabuang ta. Okay mo na siyang hitabo. So MFR of the water is the mass flow rate of the oil is 9,800 kilogram per hour. And then the heat of oil is 2000. Uy, mabuang si ko aling problem solving nga. Okay, and then I just write this because this is very quick to understand. But I found out there's a lot of errors. Here, let's say here. Okay, okay. This is one of the universities in, I don't have to mention, to protect the identity of the university. Okay. And it's not also good to discriminate and to criticize, different universities, and we need to protect, right? So I don't want to mention. Okay, so he said here also, I don't know where this it come from. If this come from the book or by having their own problems. Okay, this week, see, like this, okay. Kilogram per hour is not specific capacity. And specific heat of oil is, it's okay. Specific heat or specific capacity is just the same, right? Okay. So, say that heat capacity. You get the point? Heat capacity. So there are three. But the main clue there is there's a heat, there's a capacity. Okay, so for example, specific heat capacity, and specific heat. Maura gid na siya. Sa dili putang ang capacity, mauna nabut pasabot ha. Okay? So ka variation in how that physical property being phrased in the problem solving. Sometimes specific heat only, other specific capacity, other of heat capacity. But the more technical and precise one is specific heat capacity. Is the more perfect technical term for that, ha? Pero it's understood na talaga siya if the books, some books will say specific heat and heat capacity. So, the perfect is specific heat capacity. Okay? So, sabutable siya. Okay. Now, okay. So, kilogram per hour. And then for the mass flow rate of the water. Mass flow rate of the water. So let's say NFR water, right? So 8,000 kilogram per hour. Notice to our mass flow rate, okay, the mass flow rate of the oil is heavier than the mass flow rate of water, ha? Because oil is denser than water. Okay? This oil has a higher density compared to the water. That's why the oil will goes up and the water will goes down. They will never dissolve with each other. Okay? They are immiscible with each other or insoluble with each other. Okay guys? It's very clear. So, pababaw dyan ang oil. Okay? And then kung mag-contact siya, so it depends na siya kay in horizontal man siya, diba? Di mo mabibawaan kung pataas ba siya or paubos because they are moving in a horizontal manner. Okay? So how can we analyze that? Okay, ganon. So later. Charot! Okay. Ganon. Okay. And then guys, okay, and then the mass flow rate, okay. Determine the heat exchanger area. Area ang atong required. Okay, area. Okay. Overall heat transfer coefficient. Oh gosh. No, it's not. Heat exchanger area, heat transfer rate. Rate transfer rate or rate of heat transfer. Okay, so Q. Okay. Again, rate of heat transfer and heat transfer rate again. So there's an hour and second or minutes in the denominator. You get the point? Because it's not asking only the heat energy. It's asking the rate. So there's a difference, right? When you say a rate and a heat only. So heat only, so calorie, joules, like that. So those things are very basic, but sometimes we will get confused somewhere along the way. Di magdadali ta, di ba? Okay, so Q, una siya. And then find the length of the tube, the inner diameter. So the length. Okay. So what is being asked? Area, rate of heat transfer. Actually, this is ano siya, guys. Q, okay, Q over dt. Okay, like that. dq over dt, supposedly. But let's just put that as Q. Anyhow, we will understand that there's a second or hour in the denominator. That would not matter, right? Okay, but the precise also is dq over dt is the rate. Okay, like that, but never mind. That's just the same. Let's put that in that way. Okay, so we need to use the formula of the heat transfer. Rate of heat transfer is equals to U area times the delta log mean temperature. Ganon. Okay. So, kani siya guys yung formula. This is usable formula in all type of heat exchangers. Okay, Q is equal to UA delta TLM. Sometimes also we need to put F beside the overall heat transfer coefficient if it undergo fouling. Fouling. We need to get the correction factor of F, especially if there are many passes somewhere along the way in your heat exchanger. It will pass to another stage, blah blah blah, chupa, especially the shell and tube heat exchanger. But in here, this is not a shell and tube, so this is only double pipe heat exchanger counterflow. So there's no issue for the fouling correction factor F. So we don't put F here, huh? So it depends on the problem you are dealing with. Okay, so let's check the formula. Okay, so many unknowns. A, Q, like this. So Q and A are unknowns, and then you can get the length if you have already the area. Okay, area is equal to pi dl. So bingo, there's a diameter and there's a pi 3.1416. So it's very easy to compute now. If you have the value of area, you can compute for the length. So we need to solve for the area here. So since we have the temperature, so we can deal with temperatures later on. Then our only problem left is the Q. Since we know that this is a steady state flow, again, by theory, we need to establish equilibrium principle. Okay, equilibrium principle is very necessary in a steady state flow. Okay, meaning to say we undergo the law of conservation of energy and the law of conservation of matter in here, which we are referring to thermal equilibrium. Okay, what goes in will be equal to what goes out, something like, especially this is counterflow. If it's a counterflow, they will meet with each other. When they meet with each other, then their temperatures will be shared among them. They will be combined. So meaning to say, the temperature of the oil will be also the temperature of the water because there are only two substances in here. So, again, understood that the Q of the oil or the rate heat transfer of oil will be equal to the rate of heat transfer of the water. Take note, this is only applicable if two substances involved. Now, what if there are 3 or 4? Okay, so like that, so it's another story already. It depends where you put the input and the output also. Okay, so that's, if you will understand what will be the substance you will be feeding, so add that 2 if you have the same direction. Okay, and then if the output also have the same direction, let's say add that 2 also. Ayaw dyan siya irambol, kaya marunong dyan mo anak siya. Bisag pila pa na siya ka substances sa imong feed. Okay, igor gina siya i-add, kaya pareho mo siya direction. Okay, going in into your feed and then going out to your feed, i-add sa ito mo siya kung sa imong lusot dito in your products. Okay, streams, that's what we call streams in in higher approach of minute operation. Streams flows. Okay, and streams feed, streams flows, and blah so. Okay, so then so Q is equal to U delta M. So guys, If you know the rate of heat transfer among the either the oil and the water, then bingo, you can solve for the area because you have the delta TLN. Delta TLN is equal to delta T1 minus delta T2 over Ln, natural logarithm of delta T1 over delta T2. So today, how can we obtain delta T1 and how can we do delta T2? It's simply a change or a gradient between the T1. So all of the inner that will meet in the counterflow. Later on, we will illustrate that in the drawing. So, for example, if the oil will go in the end, it will enter here, sugaton siya for example, yung water that is very hot. So, normally, sila yung magtagbo. So, moto siya ang delta T1. Okay? Then, nandito sa magtagbo, kaya magawas man sa ito ang oil ito, yung masugat sa dito ang kuan, somewhere along the way mo, combine sila dito, so maganda siya ang delta T2 sa tumoy, sa endpoint. So, in the initial point, in the final point, like that, and then you can bingo, you can have the delta T1, the delta T2 after analyzing your flow of your temperature streams, something like that. Okay? So, you can solve now. Okay? I'm just teaching you how to solve directly before going further. We analyze quantity per quantity so that we can solve easily. It's going to be like that. Then even though you will not solve a lot, you can really understand. Okay? Because what are being asked is here in the formula magyud siya. Okay? Unless nasa mga analysis, okay? So, you apply the theory. Okay? Like that. And here also, if you don't have theory or knowledge on equilibrium principle, steady state flow, munganga na ka anak. Mayabo ka. Okay? Because nga nung mayabo ka, kay dili man mo ipareho ang heat kung wa kay kalibutan, what is an equilibrium principle in the law of conservation of matter and law of conservation of energy. Okay? Mo gina siya perdigan sa mga overall material balance, component balance, you always treat that in equilibrium because it's not always governed by unsteady state flow. Okay, it's always steady state flow. That's why we need to establish equilibrium at point 1, at point 2 will be equal to each other and go to another, medium and then budding 1, 2, 3. For example, if you have 6 heat exchangers, then break that up. I will solve heat exchanger 1. After that, heat exchanger 2, heat exchanger 3, and what will be the flow for this? So you will analyze also where it goes so that you can connect to the other, unit. And somewhere along there always have equality in the rate of heat transfer, or else it will make your computation complex. Okay, so this is very good because this make our solution simplified because of the steady state flow. Okay, without that, mangangatantanan. Okay, all engineers will find difficulty if there's no equilibrium principle. Okay, especially in engineering, always use that one, steady state flow, steady state flow. Okay, and then you have to, equate, blah, 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 so and so, chuba, chucho. Okay, if you don't know that concept, mayabog yun ka. Okay, like that. Okay, in here ba, na yung sa diri, walay value. For example, the heat of oil is equal to the heat of water. And somewhere along the way, the oil don't have all the units, the quantities, but the water had. Like that, so we need to adjust. Okay, so going back. My gosh. Masabi na itong problema, guys. Itong problema, guys, di ba? Ang specific heat capacity. I-express din niya sa 4,100, masa to eh? 4,180 joules. Ano siya? Kilogram per hour niya. Mas short sa yun siya. Okay, then, so we need to say that this is also, parallel na to siya, guys. So it's gonna be joules per kilogram Kelvin lang siya yun. Okay? So, muna siya yung matabo karon. Okay, kung ato i-convert siya joules per kilogram degree Celsius from 1 calorie gram degree Celsius, we have 4,186,000 joules per kilogram degree Celsius, which is very far from the given in this problem. Ibutang talaga, nasa yun na siya, pagbutang unit, then we need to parallel to the oil. Okay, 1,000 man ang oil, 1,000 sa di ang kuan, ang water. Okay, di kayo siya layo ba? Okay? You get the point? Because if 4 million something, and then the other one is 1,400, so this is not logical already. They are both fluid. So if they have specific capacity, if one of it having a higher specific capacity, so it will not go too much or beyond for that particular value for thousands. It will never reach millions, right? So this 4,000, this 4,184,000, okay, joules per kilogram degree Celsius is not practical to pair with the 2000 joules per kilogram Kelvin of oil specific capacity. So we will adjust that also in parallel to the oil. So let's say 4,180 joules kilogram, okay, kilogram Kelvin. Get the point? Okay, para bukod siya ba? Kaya mo assume man ni guys.
Cell battery.
Mas yung gitaan kay ano, sa'yo bayaan ng unit. Okay? May tago karong higayon na. Wow. Oh my gosh. 280. 280 is our overall heat transfer coefficient. So U, capital U, nanata U. O di ba? So 280 watts per meter squared. So the siya Kelvin, right? Yes, Kelvin. And then another analysis also, guys, since our overall transfer coefficient is in Kelvin, let's also try to have our specific heat capacity in Kelvin. Okay, got the point? The only error here is the specific capacity of the water. And through that, it makes us complicated to, to what is really the unit for this? Okay, so there's a clerical error. Okay, in the sample problem like that. Okay, now, so we need to use the equation, very popular equation in thermodynamics, which is the heat energy is equals to QmC delta T, or Q is equals to mCp dt. Okay, something like that. The Cp there is a specific heat capacity also, and the C there also is a specific heat capacity. Okay, the P there stands for a constant pressure, so it's Cp. Okay, like that. So this will only be used pala siya at constant pressure. This Q is equals to mCp dt, because there's also Q is equals to ncv dt, meaning specific heat at constant volume. Okay, Q ncv dt. And then there's the number of moles, then that is still heat, and then there's a molecular weight, and play around the units, so you can cancel the moles, and what will be left is the gram. You can also get the heat energy, blah blah blah, convert to energy like that. So I can block it, nahimo siyang N. So N is the number of moles na may molar mass. Okay, so imo nang daogon dito, i-multiply nimo or i-divide nimo, so mahabilin ang grams mo parihara sa Q is equals to mCp dt. Okay, so ari lang po sa Q is equals to mc delta T. Okay, dili sa katong mga constant pressure at constant volume. Okay, thermodynamic properties man to siya, itong mga isochoric at constant volume, okay, isovolumetric, isobaric, okay, adiabatic, no, there's no heat loss. Okay, at constant temperature, that is also isothermal, something. There's iso, chuba, chucho in the thermodynamic properties, and you must understand that also where it applies. Okay? Get the point? Ayun, basta-basta solve lang yun. Hindi nyo i-apply ang mga theory about that, where it will be applied. Okay? So, ganon. So, si metabolin higayon na. So, ano siya nitabo, guys? So, a specific heat of water is 4,000. So C, water, is equals to 4,180, okay, joules, kilogram, Kelvin. And then for the oil is 2000 joules kilogram Kelvin, right? So the denominator is in terms of Kelvin, then our temperatures in the data are degrees Celsius. So we need to convert that first before going further. Okay, so the temperature of the oil starts from 85. So 85 plus 273.15. Okay, temperature of the oil. So 85 plus 273.15, guys. 273.15 plus, nakakaloka, 273.15 plus 85, this is gonna be 358 Kelvin. And then the outlet temperature of oil is equal to 55 plus 273.15 is equal to 3.28.15 Kelvin. So these are the temperatures of the oil. Okay? Temperature of the oil inlet and the temperature. Okay, so we need to add 3.15 is equal to 298.15 Kelvin. Now guys, your outlet temperature of water, okay, so we can solve this through applying Q is equal to MC delta T. Now compute for each heat energy of the oil and the water, okay, and let's have the steady state law principle of equilibrium principle, okay. So mass flow rate of oil is equal to the mass flow rate, no, not the mass flow rate, the heat energy, or it could be also equal because somewhere along the way they will move in equal direction when it's sharp. Okay, so magkuyog man silang duha somewhere along the way. So we can say also, right? You get the point? Because there's law of conservation of mass also. So they will go with each other. The law of conservation of mass, the law of conservation of matter, the law of conservation of energy. Okay? So that's why this will be equal all throughout. Steady state flow. Okay? So in a steady state flow, that's why it's called steady, the time and period interval is not relevant. Okay, we assume at a constant time at any given t. Okay, t there is not an issue. Okay, so a steady state. Okay, like that. So we need to say mass of the oil. But before going further, guys, since the oil will be cooled, okay, let's just reduce the subscript because there's a lot of subscript here. Okay, to make it more fast in writing also, let's just let the subscript of oil as C, small letter C, meaning cool, because it was being cool, okay? And then for the water also, okay, it will become hot, right? So if this is, it's gonna be like that, and then it's gonna be TH, okay, TH, T capital H, okay, something like that. Or the first letter of water. You get the point? To understand lang ba? To have an additional understanding quickly. Okay, like this. So mass flow rate of the oil and the mass flow rate of the water, and then through its heat energy. But we need to equate the heat energies of the two. Okay, first, of course. Okay, so we can say, guys, that a QC, this is the quality control laboratory. So QC meaning this is the rate of heat transfer of the oil, because I said earlier C is the subscript of oil because it was being cold. Okay, and then equal to QH. Gonna be like that. So QC is equal to QH. Okay, QC is equals to MC CC delta TC. Okay, something like that. You get the point? So this is MC, you should be consistent ha. MC CC delta TC is equal to MH CH delta TH. Ganon. So we have the MC, we have the CC, and we have also the delta TC. Okay, MH we have the CH and delta TH. But in the H, we don't have the outlet temperature of the water. Only this is the problem. But the three temperatures are given, let's substitute values. Okay, like that. So mass of the oil, mass worth of the oil is, oh my gosh, 9,800 kilogram per hour. Oh guys, this is also one trick for the questioners, okay, especially in our course chemical engineering, because this is a flow rate in terms of hour, right? And then most of us, including me, we will use this directly in our equation. But be clever enough that some of your constant here, especially the K, this is the most error of engineering students, because our overall heat transfer coefficient, guys, is watts per meter squared Kelvin, and there's no time yet there, right? There's no time yet there. So for you will feel that this R is not yet relevant. You should substitute this directly all throughout, because there's no hour in your area, there's no hour in your TLM, and there's no hour in your overall transfer. You will substitute this directly, and after you will convert. But take note, this will not coincide and parallel for your overall heat transfer coefficient. Take note, this is the most mistakes. Okay, again, our unit is watt per meter squared Kelvin, and take note, there's no time there visually. You get the point? So if we try to substitute this 9,000 kilogram per hour, it's okay. Okay, because it's not an issue here, because there's no hour in our other quantities. Okay, but that is only deception. Your deception trick to confuse the examiners and the students. Take note, as I told you, 1 watt is equals to 1 joules per second na siya. So meaning to say, this 280 watts per square meter Kelvin will be equal also to joules, okay, per meter squared second Kelvin. So there's time already if you break that watts. Now, in your mass work, there's an hour. Convert the hour in seconds first before you substitute in your heat energy, because you will become wrong immediately. Okay? And if you will try, because this overall transfer coefficient will be used in the beginning ng siya. Okay, so you convert also this in the beginning. Use this in the beginning. I need to say 9,800 kilogram per hour. Convert it into kilogram per second first before you substitute, because if you will not substitute, if you will not convert this, convert in your final with your unit of your overall heat transfer coefficient. So this is the most mistakes. Yung ani ko sa una, mistake ko ani. Really. Okay. So 9,800 kilogram. So 1 hour, minutes until hour, like that. So, dugay kayo mahuman. Okay, 1 hour, 60 minutes. 1 minute, 60 seconds. And badin, cancel. So, 1 hour is equals to 3,000. I-memorize na lang yun siya. 1 hour is equals to 3,600 seconds. Get the point? Okay. So, 3,600 seconds. Efficient na talaga siya. Okay. Joules, kilogram, Kelvin. Cancel kilogram. Ang mahabilin, joules per Kelvin. Kung saan nga unit ang joules per Kelvin class? If we will not multiply it with temperature, this is the unit of entropy. The randomness and the disorderness of molecules in its microstate. Something like that. Discovered by Mr. Ludwig Boltzmann. Okay, that's why we have the Boltzmann's constant of 1.38 times 10 to the negative 24 joules per Kelvin. Okay? Get the point? So, muna siya natabo. So, sa ito guys, entropy also is mass times specific heat capacity. Dihara. See, I can create another formula for entropy. Okay, by just looking with this equations, things like that also is very useful. Okay, because this is not taught in our college that this has another entropy formula. But if we try to be observant also, just like this, okay, and then P of the oil is equals to the mass flow rate of the oil, ganun siya, okay, times the specific heat of the oil. Ganon. Yan. Imong tangtangon ang seconds. Okay, so how can we tangtang this one? So, ang problem, state siya on time. Wild imagination, di ba? To become an engineer, you have a wild imagination. For example, if I have an oil, we'll go to the double pipe heat exchanger. So since I have a formula of entropy that is only mass flow rate times the specific na akong gimugda-mugda nga ako ra. Okay? Na wala gitudlo ba? For example, okay now, joules per kilogram second siya. And then ang problem na, at 2,600 seconds, an oil will travel a mass flow rate of 9,800 kilogram per hour at 213 Kelvin. In that alone, calculate the entropy of the oil in going to the double pipe heat exchanger. See, I can create my own problem if I have knowledge to the formulas and equations that we memorize. Okay? Okay, wala ba ginagitudlo? Okay, ang ato bang entropy? Kung ano ba dito atong entropy? Kung ano ba dito na heat over kung ano ba dito siya temperature? Okay, naman ang tama. Entropy times temperature man imong heat, total heat content. Okay? Okay? Entropy is equals to joules per Kelvin. So, entropy will be the heat content over the temperature. Moro gina siya ang formula sa entropy, wala na ilain. Then, karon on the spot, nagbugna ko because I saw the unit is joules per Kelvin. So, wala pa na ako i-multiply ang temperature. You get the point? So, which is possible if we give time to the fluid in going to the heat exchanger. Wala siya pares. For example, water lang din siya ni, wala siya pares ba? Wala yung counterflow. Okay? So, wala siya wild imagination. To become an engineer, you should have wild imagination, observant, and have critical thinking. Okay? Kada lang siyang tuludaog na yun siya. Okay? So, nanamang ginadaan ng mga memorization. Okay? Because you will never become an engineer if you never memorized. That's 100% sure. Okay? Kaya bisag density lang, imo naman na siyang i-memorize. Okay? As simple as that. So, you will never become an engineer if you never memorized. Okay? Got the point? So, given na nang mag-memorize ta. Okay? So, you should have critical thinking, imagination, and to be observant. Usually, to be observant is a quality of a scientist. Observant. Okay, not necessarily with the engineer, since we need data also for our calculation of our engineering design. That's why we need to be observant. Okay, in that way. So, when we are observant, we look the things around us. Meaning to say, we need to consider the matter, M-A-T-E-E-R, because the world composed of matter around us. What we will iskapo ana niya, guys. All are matter, M-A-T-T-E-R. Bisag mag-mention po mo, bisag kung sa diha. It's matter. It's always solid, liquid, and gas around us. Hantod sa kamatayon. You get the point? When we die, we will be buried in the land. And land is a solid. Okay? Like that. When we drink, we need water, and that is a liquid. When we run our, car, it needs gasoline, petrol, fuel, and then that is a gas. So the world that revolves us every day is a matter. Okay, so meaning anything that occupies space and has mass is what we call as matter. And if we understand matter very, very well, then we can easily understand science or pure sciences. Because this matter will always be used in our calculations and our problem solving in higher engineering subjects, especially related to pure sciences, something like that. Okay, and this is an example of pure science. Okay, talking about heat energy. Oh my gosh! Okay. So nausab ang atong puntarya because naka-observe ko, oh, yun, entropy siya. Ganon. Okay, so times delta TC. Our delta TC guys is oil. Now, I draw now. Dugay ko ni drawing no. Pero actually guys, pwede rin mo drawing diretsyo sa double pipe heat exchanger. Okay, para dali. Pero ako lagi nagyaw-yaw pa man ko because I put the data, the concepts, the theories like that. So it's up to you. What is your convenient and comfort zone to draw first, illustrate first? It's gonna be like that only. There's no such rule. Okay, as long as you understand, you can do whatever you want, you like. Okay, so this is only a guide. Not really that specific that you have to apply. Okay, because we have different approaches or different approach how to solve the problem. Okay, or strategy. Get the point? Method, strategy, approach, procedure, scheme, okay? Method, like that, way, are the same terms. Okay? Get the point? Or a protocol. Something, or a system. Okay, so many vocabularies have the same meaning, closer to each other, okay? So, ganan. So, delta TC guys, mag-drawing ako double pipe exchanger guys. Uy, lugay ko ni drawing mo in fairness. Charot. Okay. Mo ni siya atong double pipe exchanger. Okay. Ganun siya. And then ang oil, the oil will go in the temperature of oil is 358.15. So already until 35.18 goes down to the inlet also, counterflow to the water. So this is TCI because inlet na siya. You get the point? Mo ba ni siya? Kaloka. Yes, because let's analyze. If the oil will go here, so the oil cannot move because it's downward. Normally, it goes down initially. Get the point? So wala siya sense kung imo siya init din sa ubos and then there's a gravity. So it will just fall on the ground. Unless there's a hose and you will pressurize that one by a motor pump. Have a, let's say, 8,000 horsepower like that, or 1.3 million watts, so that you can move that liquid pressurized move upward. But normally, under normal circumstance, without using any pressure, it will not move. So by common sense, your inlet will be going down for the counterflow. You get the point? Kung maglibog mo ba sa inlet din yung outlet, so nauna lang din ninyo ha. Okay guys. So TCI meaning inlet oil temperature. Charara. Okay? So I have to end this live streaming because I have an appointment. Later I will come back for my part 2 discussion and live streaming of this heat transfer. I still have 20 minutes chart. Okay? So this is TCI. The TCI guys is 358.15 Kelvin. Okay, come on. So TCI 358.15. Okay? And then your TCO, meaning go out. So it is obvious it will go down, so the temperature will be lesser. So 328.15 Kelvin, because in heat transfer, okay, it will always be in the direction from higher temperature to lower temperature, which is our theory valid. From 358.15 to 328.15. Ay, dyan pugsan yung ibalin ninyo ha. Okay? So, 3, 2, 8, or else manigative pud baya siya. Okay? 15 Kelvin. And then this is the oil. Chuba chuchu. Ganon. Okay. So, our purpose of water is to hold the oil. So, mo nang ipasok sa atong brain cells, the purpose of water here is a coolant. Meaning to say, this functions to cool the oil substance in a counterflow in our heat exchanger. Okay, so this is water here, let's say H2O. And this is the temperature going here. This is THI. Okay, THI is given also in the problem, which is equal to 298.15 Kelvin. Kakaloka. And the THO, you don't know. THO, you don't know. The outlet temperature of water. Guys, these things should not be memorized. Here in this part. They should not be memorized. Only the theories, concepts, principles, and formulas and equations to be memorized. But here, this needs analysis. Here in the illustration. Because if you memorize, it will create, it mix up. Okay, so don't memorize if you illustrate in solving this kind of problem. Okay, especially if there's drawing, the schematic diagram, like that. Do not memorize the location where it goes like that. Just understand. Okay, so if you do memorization here, problem. Because the problems will be modified by a good siya. Okay, not only the same ala dili ala pool. Charot. Okay. Sometimes it will be changed. Okay? Or most of the times it will be changed also. And sometimes it will come back the same as it is being presented like that. So expected and unexpected. That's why you have to understand that. You have to analyze what's the behavior, what's the mechanics for this. Okay? But for the formulas, equations, theories, concepts, okay, you need to understand before you memorize, no problem. But then you don't memorize, okay? Always take note that it will have from higher temperature to lower temperature din siya ang heat transfer. You get the point? It will never be from lower temperature to higher temperature. Okay? So, gano'n. Now, so, dali ari guys. So, naitabo na nga ng higayon na. Now, kani siya, on the spot man ako siya, no? Because this is the first time I saw the problem, something like that. So, in here, nakadrawing kong ingon ni Ani. Okay? So, my heat exchanger is valid for this. Valid ba siya? Valid ba siya yung Ani? Or dili? Tanawa, good. Okay? Valid or dili? Kay, ako na pala hidup, what I remembered class talaga. Okay, in my first, this is analysis also, this is also okay. Because I told you, you will never memorize, right? Okay, now, as you can see guys, if the inlet here are all THI and TCI. Okay? Okay, so, seldom project kayo na siya sa mga problem solving na ang puro initial nag-abot. You get the point? You get the point also. The gradient ba, the temperature gradient, puro siya initial ang mag-abot. So, naagyo na siya sa outlet na gayon na. Especially kung counterflow. Wala may problema ang direction. But sa nalagit siya outlet, inlet, out. Hindi rin mo good inlet siya puro. So, it looks like, what do you call this one? Unrealistic. Though, the direction is okay, but it looks like unrealistic in a practical approach. Okay, so how can I do this? So just treat this as your first option. Kung nag-doubt ka, yung anong hitabo. Okay? First option, di ba ganun ko? First option for option, second option, unless I memorized everything. Okay? And then I have to do it perfectly without any errors, right? As I told you over and over again. Okay? So this is first option. Because honestly, I forgot the opening of this dual private exchanger because that was very long time ago, 20 years ago. Okay, now I'm very old. But what I understand, there's a hole on the inlet and the outlet. And then if this will not hold, so let's take option 2. So let's reverse this one. We need to put the opening here as the TCI, and we need to put the outlet here. Yes, it's possible. So that you can have an outlet temperature and an inlet temperature together. Because what I understand and retain in my brain cells, you can never have all initials or I in your data TC. Okay? You got the point? Ano man ang on the spot good ng mga create ka ba? Magdali na ka makakuan ba, makasabot, o imong madiscovery o sa mga valid or mga unrealistic or mga hindi siya pwede, okay? So dihan mo makita ang katag if you analyze na talaga siya. Okay? So in this manner, so I can say, oh my gosh, TCI and THI or I initials, I will adjust now the opening. Because as I said earlier, I don't memorize exactly the opening because that was 20 years ago in my chemical engineering. Okay, so how can I memorize perfectly for that? And in fact, I'm not working in the heat exchanger also now. Okay, so I don't know where exactly the opening, basta if I see that, I can easily understand. If there's a heat exchanger in my front now, I can really get the point. Normally, if you don't see the object, this is the inlet that the oil will go here on the night. So since I am only in the room, so there's a possibility that there's an actual error if I will go to the field. And I let somebody, for example, if I have 20 students, let's go to the plant industries and now let's discuss this is for topic and I'll show you the inlet of the oil that goes so that we validate our theories and problems solving in the classroom instruction. So there's no such like that. Okay? You get the point? So and this is on the spot, so we need to reverse. Okay, reverse na to siya guys. Okay? O diba at least na correct siya in early stage. Okay? But we still don't know yet because this is only option. Until such time we can get the correct answer. Okay? Yung ano siya ko ni sa college. Okay? So, ganun siya. So, this is your double pipette exchanger. So, nagyan po siya diri ari. Chararat. Okay. Diri na lang ni siya, anak. Okay? Guys, ako na siyang gibali, guys. Kaya nakamatikod man jud ko. Mapuro ini siya, di man siya pwede sa kuan, sa rule. Okay, nga na jud atong timanan. Kailan sa kinamasikag sa guho, yung makakasabot, di ba? So this is THI is equals to 298.15. Oh my gosh! Wait for a while. Guys, sorry kaayo, I have to end. So where did we stop? We stopped in the second option. We need to reverse, okay? Because it's not practical to solve, in which I doubt this is not possible, okay? Just like that. Sa'yo pa siya, may bawa na bigato, what's the error behind? Technical error, something like that. Okay guys? Muna siya may tabukang higayuna. Okay, thank you so much for listening for this live streaming, a very lengthy live streaming. It reached to 1 hour and 27 minutes. And if you think you like this video, you can comment down below in the comment section, and you can subscribe to my YT channel, and you can click the notification bell for some newest updates of I Am a Singer Eternal Voice, for some academic information pertaining to pure sciences, a little bit of mathematics, okay, and also personal vloggings, and also kantahan or whatever occupational safety and health. And please do subscribe my channel if you want also. Okay, bye bye. Let's do the second segment. Okay, I will be back to continue my live streaming. Sorry guys, this is the first part and the second part later. Thank you so much. Bye bye, everybody. So we stop here, right? I need to discuss this. Okay, here. Okay, so we are now in the option 2, and then we need to reverse the outlets of our heat exchanger. We need to rotate something like that, okay, to make it passable in our theory and principle, because it's not logical, right? Okay, thank you so much. Bye bye, God bless everybody.